Geometry, Chapter 10, Section 3, Arcs and Chords. So a chord is a segment with endpoints on a circle. So if I have a circle, I can have two endpoints making a segment. That red line there is called a chord. If it's not a diameter, you can see it cuts the circle into a minor arc and into a major arc. Now, if it is the diameter, it just cuts it into semicircles. Um, an interesting thing about chords is if the the minor arcs that are made from them, or major arcs too, I guess, but the minor arcs that are made for them is usually what we talk about. If those minor arcs happen to be congruent, well, then the chords that made them are also congruent, which makes sense. If you cut off 30 degrees of a circle, and then the other piece also cuts off 30 degrees of a circle, well, then it's probably the same length of the line that cut it off. That's the idea. And it works in converse as well. If those chords are congruent, then what's left over is the same. So that's actually what we're going to use here in the embroidery hoop, which you can see here on the right. The two chords, A, B, and CD, are congruent, and the measure of AB is 60, which means the measure of CD should be equal to the measure of AB, so it should also be 60 degrees. So we're just going to say the measure of CD is 60 degrees. Not much work to do with that one. It kind of gets a little bit more complex when it asks for that, and then it says, well, what's the measure of the arc of ACB? And it gives you some major arc or something, and kind of like mixes things around. But if it's just chord to chord, then it's arc to arc. Arc to arc, chord to chord. Let's do another example here. Use congruent arcs to find chord lengths. So this is where it can kind of step up a little bit, kick it up a notch. So here I have two congruent circles. They tell us that. That is an important piece of information. If they're not congruent, I've got nothing. But they are congruent. So I know that the two arcs, you can see they've marked them here. They've marked the arcs and they are congruent, which means their corresponding chords are congruent. So MN is going to be equal to PQ. Or we should start, I guess, with the segments are congruent, which tells us the lengths are equal, which means their expressions are equivalent. And I go ahead and I solve for x, and I get x equals 8. But that's not what I want. I want to know how big PQ is. So all I have to do is plug in that value of 8 for x into PQ's expression, 3x minus 7, or 24 minus 7, which is 17. So PQ equals 17.